And here we go. Okay, lesson 1, 2, solving linear equations. If you took pre-algebra, you've done linear equations. Okay, if you didn't take pre-algebra, you've done linear equations. You just didn't know they were linear equations. Okay, so when we solve an equation like 4x plus 3 equals 19, that's a linear equation. Okay, you just didn't know that because we didn't call it that. But we're not going to do, I don't think, anything super surprisingly brand new in this lesson for you guys. A lot of this should feel familiar, hopefully. So we're going to explain that each step in solving a linear equation follows from the equality in the previous step. And we are going to create and solve linear equations with one variable using the properties of equality. So one variable. You've done one variable equations before. All right, here we go. Joshua is going kayaking with a group during one of his vacation days. In his vacation planning, he budgeted $50 for a kayak rental. How can Joshua determine the number of hours he can rent a kayak for himself? Describe two different options. I feel like we're missing something. Are we missing some information?
Probably.
Am I missing a slide?
I think we have to go into the next question. No.
There's $25. I feel like I probably forgot to put,
It needs
well,
to,
let
it
me
needs
check
to
the old
say,
book
like,
here. I forgot part of the picture probably.
Oh, well, I think
It needs to say like
A and B just got switched.
I think we just have to
Well-
put a variable.
Yeah, lesson 2, hold on. Checking,
Are these the answers?
well, there will be answers in here. Okay. Oh yeah, there's supposed to be a picture.
Oh, that makes sense.
Okay, sorry about that. How funny. Yeah, there's a whole picture over here I forgot to put on the slide. So single kayak is, let's see, here we go. Single kayak is, I don't have a lot of room to write here, $15 per hour. Single sea kayak, like SEA, for going out to sea, I guess, in a kayak, is $18 per hour. And a double kayak is $25 per hour.
Wait, what's the first one?
That is just a single kayak. That's just like a one-seater for going down the river, I guess, or in the lake. And then the other one, the next one is a sea kayak, I guess, for going out to the ocean. And then next would be a double kayak. So now, sorry about that. Now that we have some information, can we write an equation? How can Josh determine the number of hours he can rent a kayak for himself? Describe two different options.
You could do $15 or $18.
Okay, so $15 per what?
Hour.
Per hour, so 15 times H. Okay. Needs to equal what?
50.
Needs to be less than 50, right? He budgeted $50 for a kayak rental. And we are, yeah, they're just using, for now, we're just using equal signs, so we can actually do partial hours, I guess, is what that's gonna end up with. So you can end up with a part of an hour and pay the,
Full
pay
price.
the full price, pay the whole 50. Or what would be the other way we could write an equation for him? If he wants a single kayak for himself, Enzo.
Less than or equal to?
We could do less than or equal to if we wanted to write it as an inequality, but we're sticking with the equation. I don't know why they gave us an inequality problem. It would work better that way, but
18.
okay, we could also do an 18H equals 50, okay? Because he could rent a single sea kayak. Okay, so far so good. Were those hard equations to write?
No.
Not particularly, all right. Joshua Part B found out that there's a $25 non-refundable equipment fee in addition to the hourly rates. non-refundable. That means that goes right off the top, right? So,
He only has $25.
so really he only has 25, so he would have the $15 per hour plus the $25 equipment fee, and that has to equal $50, right? Okay,
Okay.
alright, so something like that, you have to take into account all the parts of the problem. Alright, let's move on from there.
Is that all they wanted us?
That's pretty much it. That's a linear equation. Look for, how do the processes you use for parts A and B differ? How are they the same? So what was different about those two equations?
One had a, don't remember what it's called, like a number that doesn't have a
What do you call a number that doesn't have a variable?
I,
Starts with a C.
Coefficient.
Starts with C, ends with constant.
constant.
A constant. I thought you said, I didn't hear the word constant. I apologize.
I said constant first and then I said coefficient.
Oh, I heard coefficient. I didn't hear constant. My bad. I would have given you props had I heard it. Now we're just guessing that you said it. We're just taking your word for it. All right. A constant. So you have to think about the words that we use. A variable is a letter, right? We call letters variables. Why do we call them variables?
Cause they bear.
Yeah, from one problem to the next, it's gonna be a different number every time, right? But a number is called a constant. How come it's called a constant?
Cause it's
Lucy?
constantly there.
It's the same value. Every time you see the number 25, it always means the same thing, right? 25 is always 25. We're not gonna change what 25 is. All right, so numbers are constants because their value doesn't change. Letters are variables because their values change from one problem to the next. Okay, that makes sense? That's why we call them that. Now, the word a lot of you said was coefficient. What's a coefficient?
I don't know.
The number, it's the number times the variable.
The number in front of a variable. Okay, so when you have 3a, 3 is the coefficient, a is the variable. Together, those two make one term. 3a is a single term, but the 3 is a coefficient, the a is a variable. Okay, all right. All right, let's move on. Oh boy, look at this. We get to solve some equations.
Oh boy.
Yeehaw. This is a linear equation, by the way.
+8.
So, okay, so our job when we're solving an equation is to get the variable by itself, right? We want the variable to be isolated. So I start stripping things away from the side that has the variable on it. First thing I can do here is I can take away this -8 by doing the opposite. Add 8 to x plus 4 over 3 equals 40. Okay?
Times 3.
Times 3 to get rid of the fraction. I like that step. Multiply everything times 3. So that would be 2 times x plus 4 equals 120.
Wait, wouldn't it be like 6 times x?
No, because on this side, these 3's just cancel out. That's where the multiplication
Oh,
happens,
okay.
just to get rid of that 3. Yeah. Okay. What would I do next, Lucy? Ooh, I could. I absolutely can distribute next. Yep, that's a good step. Nothing wrong with that. So 2 times x
2x.
is 2x. 2 times 4
8.
plus 8 equals, equals 120. Now what?
Minus 8.
Minus 8. Two x equals 112, almost wrote 102, 112. Then divide by 2 is our last step, so x equals 56. Okay, let's go back a couple of steps. What's something different I could have done on this line instead of distributing there? There's nothing wrong with distributing, it was solved it perfectly. But could I do something different on that line? Could divide by two right there. Okay, so if I just take this and divide everything by two, that takes that two out, so I'd have x plus 4. And then 120 divided by 2 is 60. So x plus 4 equals 60. Then one more step, subtract 4, so x equals 56. So we get the same solution, which obviously matters. We should get the same solution. Sometimes we can avoid this distribution step and shorten the problem a little bit. Okay, nothing wrong with doing it the other way. But one of the things they want us to teach in math is efficiency, doing it in as few steps as possible. So anytime we can eliminate a step, that's a good thing. All right. That's a linear equation. You just solved a linear equation. Did that feel familiar? You've done solving like this before. Okay. Solve the equation and explain the reasons why you chose your solution method.
How do we explain?
Well, I don't know. Why did you do the steps you do? Why do you do the steps you do, I guess, is how you explain it. What's our first step gonna be?
Subtract 4. Minus 4.
Minus 4, I like it. Oops. Now what?
Times 2.
Oh, I forgot something. I wrote that out. Thank you for saying that. Times 2.
Plus 1.
Plus 1.
Divide by 3. Wait, how'd you get 10? Oh, times 2.
Don't be afraid to tell me if I did it wrong. I'd rather you tell me than we go on with it wrong. I think that's good though, isn't it? Is that what you guys got? 11/3? Yep, that's what I got. Okay. All right. Anybody solve it different? Do different steps or a different order of steps? Is it okay if you did? As long as we got the same answer, it's okay if you did. All right. Sum of 3 consecutive integers is 132. I like these kind of problems. You'll see these often as we move through. They do a lot of these as examples when we're learning new concepts, and then you'll see a lot of these type of questions on like standardized testing, state testing, or fast breaks or things like that. Okay. So the sum of 3 consecutive integers. What does sum mean? Okay, so we're adding some things. Okay, we're gonna add 3 consecutive numbers. So if I don't know what the first number is, what do I do?
Figure out second.
No, I mean, what do you put in its place if you don't know what the number is?
Oh, a letter.
We put a letter, so I'm gonna take my first number is x. But I've gotta have 3 consecutive numbers, right? So what's the next number after x?
Y.
No, single variable equations. We're gonna leave it as x,
X.
but it's not just x.
plus 1.
It's x plus 1. Okay, so I'm gonna do the first number plus, I'm gonna do the next number, which is x plus 1. But I need to do the next number too. So what is it?
X plus 2.
X plus 2.
What's consecutive mean?
Like next to each other. like
Consecutive,
1, 2, 3.
yeah, consecutive 1, 2, 3, 4, 5. Okay, so this is 3 consecutive numbers. This is my first number, this is my second number, this is my third number, and when you add them together, they're 132. So now I can combine like terms, right? X plus x plus x is,
3x.
okay, 3x plus
Three.
3 equals 132.
Minus 3.
Minus 3. 3x equals 129.
Divide by.
Divide by 3. So x is
43.
43. So what are my 3 consecutive numbers?
43, 44,
42,
45.
43, 44.
43, 44, and 45. My first number is x. My second number is x plus 1. My third number is x plus 2. So 30, 43, 44, and 45. Okay? Oh boy. A new type of problem. A lab technician, excuse me. Lab technician needs 25 liters of a solution that is 15% acid for a certain experiment, but she only has a solution that's 10% acid and another solution that's 30% acid. So she needs to mix those two to change the concentration of the acid, right? So how many liters of the 10% and the 30% solution should she mix to get what she needs? So we need to write an equation, all right? So she wants to end up with what?
15.
25 liters of the 15% solution, right? So she wants a total of 25 liters. She wants a bucket that has 25 liters of fluid in it, and 15% of that fluid is gonna be acid. The other is whatever other chemical she has or whatever. So 15%, 0.15 of the 25 liters needs to be acid, right? Okay,
Why'd you multiply it?
well, because if she has 15 total liters and, or sorry, 25 total liters and 15% is acid, then you would take the 25 times 15% times, which is 0.15. That would tell you how much actual acid there is.
Wow.
Okay, so if I had 25 pounds of candy and 15% of it was Skittles,
Okay.
you would take the 25 pounds and multiply by 0.15, okay? So, 25 liters of solution, 15% is acid. So, we need to mix the other two chemicals, right? To get this one. So, I need some number of liters of the 10% solution. I don't know how many liters I need though, right? So I put an X there. But if I've got that number of liters, how much of it is acid? Only 10% of it is acid, right? So I'm gonna do 0.10, 0.10x, or just 0.1x, I guess would be probably a simpler way of writing that. 0.1x, that's 10% acid solution, right? That make sense?
Yeah.
What's the other solution that I'm gonna mix? What is that?
30%.
The 30%. So I need to add to that the 30% solution, which is gonna be 0.3, but I can't just say 0.3x because I'm already using x to stand for the number of liters of the 10%. Okay? So can I mix, how many total liters do I need to end up with? I need to end up with 25 total. I'm using some of that to make this is gonna be this part, the other part is gonna be this. So I need to multiply the 3 by 25 minus x.
Wait, what?
25 total liters minus however much of this I used gives me how much I'm gonna use there. 25 total liters minus the 10% solution gives me the 30% solution, alright?
Are we gonna have problems this on.
Yes. Yes, we are, but once you see how to set them up, they're pretty standard, they kinda set up the same way every time. Once you've seen a couple of them, and it's like, you gotta think about where to plug numbers in at. Excuse me, I have a frog in my throat, and I did not try to swallow a frog this morning, so I don't know where he came from. So, now it's just an equation to solve. We can do our thing here. What's 0.15 times 25? 3.75 equals 0.1x plus 0.3 times 25, 7.5 minus 0.3x. Is that right? 3 times 25 would be 75, so 0.3 times 25 should be 7.5. Okay, so all I've done is simplified. I've done one step. Is everybody good?
No.
Makes sense where we're at? Okay. 0.15 times 25 is 3.75.
Yes.
Then we just have 0.1x.
Okay.
0.3 times 25 is 7.5. And 0.3 times x is 0.3x. So all I did was distribute.
Okay.
Okay? Alright, what's next? Combine like terms. Okay? With you guys, can I combine steps? Can I do more than one thing at a time? Can I also subtract 0.75 from both sides? Because we're gonna need to do that, right? We need to get the variables on one side and the constants on the other. Does that make sense? So I can do minus 7.5. So 3.7 minus 7.5. Help me out. You got a couple of you have calculators. 3.75 minus 7.5.
Negative 3.75.
Negative 3.75. Oh yeah, that makes sense. Equals negative 0.2 x. Okay?
Wait.
0.1x minus 0.3x is negative 0.2x.
Okay.
Okay, what's my last step? Divide by negative 0.2. Hey, we got the right answer. 18.75 equals x. So what does that mean?
She needs 18.75 of the 25 solution is gonna be asked. That didn't make sense.
Where does the x go in the equation? What is 18.75 mean? 18.75 what?
10%.
10% solution, okay? So we're taking 18.75 here, and 25 minus 18.75 would tell us how much of the 30% solution we need, okay? So we need 18.75 liters of 10%, and would that be 6.25 liters of 30% solution? Would give us a total of 25 liters of 15% solution. Whew! I think we got another one of those, don't we?
What?
What's the next question?
Bro, my brain is hurting.
Who, if the lab technician needs 30 liters of 25% solution, how many liters of the 10 and the 30% solution should she mix? So think about how we started off last time. We need what?
30 liters of 25%.
So 25% times 30 liters. And we're gonna mix in our 10% acid plus our 30% acid So really,
Wait, it would
whoops,
be
not
30.
25, thank you. I got carried away.
I did that too.
30 minus X, thank you for correcting that. Alright, so really, we changed one number from the original, well, two numbers, I guess. We changed this to 25%, we changed this to 30. Alright, that's all we did. So now it's gonna solve the same way. What's 0.25 times 30?
0.75.
How much?
7.5. Whoopsie.
7.5 equals, oops, 0.1x plus, is that 9? Minus 0.3x?
What?
3 times 30 would be 90, so plus 9 minus 0.3x, like that, right? Subtract 9, so 1.5 equals, negative
No.
1.5, right?
Yeah.
Negative 1.5 equals negative 0.2x. Divide by negative 0.2.
Seven point five.
7.5 what?
10%.
7.5 liters of 10%, which means we need 22.5 liters of 30%. Okay. Didn't seem quite so hard the second time around, did it? Okay. Four friends use an online code to get discounts on concert tickets. They spent $312 for the 4 tickets. What was the price of 1 ticket without the discount?
Don't like discounts.
Well, how much is the ticket price? It's kind of what they're asking, isn't it?
Yeah.
So what do we put there if we don't know
X.
it? X, okay, how many tickets did they buy?
4.
4X, but we also have to add in, do we add in or subtract in? Ooh, there's a question. We also have this 4 times 15, which is the discount, right? Are we adding that or are we subtracting that from the ticket price? Do you know how discounts work? Okay, subtract it. We need to subtract it from the ticket price to get their total bill of $312. So 4 tickets minus the $60 discount equals $312. Oop, what was I doing? Add 60.
Fast deal.
So 372 divided by 4 be 93. I think, is that right?
Yes.
$93 per ticket.
Wait, would that be with the discount?
That's the original price of the ticket. So that's the list price of the ticket,
Oh, okay.
okay? Same four friends buy tickets for 2 shows on consecutive nights. They use a coupon for $5 off each ticket. They paid a total of $416 for 8 tickets.
Wait. Yeah. there's 4.
So they bought 8 tickets minus $5 per ticket discount, and they spent $416. $8x minus 40 equals 416. Oops. Add 40. 8x equals 456. It's gonna be, is that 57?
Yes.
57 per ticket.
They bought 8 tickets.
And they must not have been sitting so close the second
What
night.
are these tickets too? Because I need those tickets. They're 50.
Oh, I don't know, maybe to see, maybe they're going to see Taylor Swift, I don't know.
Taylor Swift tickets for that cheap?
I wouldn't pay any more than that myself, but
No, definitely not for the Eras tour.
not for the Eras tour. Those tickets were expensive.
Like 1,000.
Latanya will walk her bike from her house to the bike shop, which is 1.5 miles from her house. What? I thought we had 5 more minutes. Man, I mistimed it. I'm sorry. I try not to do that. I really thought we had till 8:15.
Part 2 coming soon.
9:15. We'll finish up tomorrow.
No homework?
Well, we didn't finish the lesson, so no homework. How do I stop this thing?
I need the following students to come to the front office, please. Lauren Plantenga, Jackson Boggs, Mayron, Tig Roberts, E. Jasmine Peterson, Alec Lyle, Jake Anderson, Clara Smith, Ternan May, Zabrion
I
Green,
can't.
Uriel Atrice. And then we forgot to do